It is 2 hours UTC, time again for Astronomy Daily Live. Hey, everybody, you can call me Cosmic, and here we are again, gathering together the circle of friends to share a common passion for the science of astronomy. So, hope everybody's doing well. I when I turned on my light back here tonight, I realized that somehow now look, I am really high tech, right? When it comes to the video camera, okay, the the microphone and the lighting, okay. The lighting is a shop light, so it's just those 4 foot long tube tube lights, fluorescent lights, and I noticed that one of them was out. And the past couple of live streams, I've noticed that it seemed a little darker. It seemed a little darker, but I was just like, well, okay, it's just a little bit darker. Well, it's because one of the lights was, I don't know how, but it turned a little bit. So it just yeah, it just was out, and I noticed it. I noticed it, and I have turned it back on. So it does look significantly brighter back there. What's really cool, and I I don't know if I'm going to do this or not, but I would absolutely love to take you guys outside. Right? I mean, this is fine. This is fine. I think having sort of a regular place, sort of, I mean, as you watch this, you'll see, familiar objects in the background, like my CD collection back here. Now, uh, these are um, either um, individual CDs that are hanging on a little nail. So I just created, like a grid of nails, properly spaced, and level and straight, and all that. And then I just you know pounded these little nails into the wall, and hung my CDs on them. Some of them are singly stacked, some of them are doubly stacked, some of them are triply stacked, and they go um, from pretty much where you see it starting over there, all the way around over here. So about half of my wall, right? There are six walls in a rectangular room, and then you have the floor and the ceiling. Is that right? One? No. There's four. There's four walls. There's four walls. There's four walls. There's four. There's four walls in a rectangular room, um, and two of them are filled pretty much, well, sort of floor to ceiling of CDs. You know, I carried around CDs in those little book things for a while, and it was really a hassle to have to flip through because I really didn't have them organized in any way. And probably if I would have organized them, maybe I wouldn't have disliked them as much as I did. But when we moved here, it's like, those walls look like crap. So I'm going to decorate them, uh, and also solve my CD finding problem. So these are relatively organized. I've got them organized by artist, not alphabetical or anything. Just sort of, I know where my uh, uh, um, um, Yes albums are. I know where the Alan Parsons Project is. I know where the Doors are. I know where the Smashing um, Pumpkins are. I know where Pink Floyd is. you know, I know where all my classical is over here. Uh, sort of, all my folk is over here. So it's moderately organized. And when I want a CD, right, I don't have to flip through a book and look through things and all that. Now I know that CDs are starting to get ancient as well, but I'm an old guy, so uh, well, at least I've been around a while, and so I mean, uh, I'll always have CDs as long as there are CD players. So as long as those don't go out of style, I will be fine. I'm going to pop my chat out, and I'm going to tweet. So I've got that all. Oh, I thought I did. Oh, I don't. Let me do it really quick. Astronomy daily live now. And then I have to make the link, which is here. Like that. And I like to put a little graphic with it so it sort of pops a little bit. I'll do the same one that I did before and then tweet that out. Yay. I'm going to make sure that my live stream is running on my little smartphone here. Come on. Slowpoke. There it is. I think. Yep, there it is. There it is. There's my ear. Let's see. I've got the chat popped out. So welcome, everybody. Glad you could join again. Gather around in the circle. This is sort of like a virtual porch where we're sort of I sort of envision like a little awning, some comfortable chairs. We've got our drinks and or consumables of choice, whatever you like. I've got some coffee here tonight. Cheers. Freshly brewed. And I do have some hydrogen hydroxide tonight, my chemical of choice. The greatest, most amazing molecule in the universe right here. And I've got about 10 to the 27th of them or so in this little bit here. So cheers. I'm going to consume quite a few of those right now. Hold on. Now, I make coffee sort of the old-fashioned way. If I had my way, it would be French press. Definitely. I prefer that probably over every other one because I can let it soak, right? I can let it steep, I guess is the right term, and then squeeze it through, filter out all the granules, and you've just got this awesome awesome uh, drink. Now, the next best thing is, and I don't know what it's called, but it's the kind of thing. Um, it's a percolator that you put on the stove, right? So you fill this thing with water, and you've you've got this other thing that you fill with your ground up coffee, and I prefer buying whole beans. We have actually some local roasters here down in Bisbee. I'm in southeastern Arizona, out in the middle of nowhere, out in the middle of and quiet. Dark and quiet. But Bisbee is about an hour away drive or so, and there's a couple of coffee roasters there. And when I can afford it, I like to get their coffee because, uh, well, one, it's extremely awesome, and two, it's also it's got all the ethics, right? The farmers are treated right, the plants are treated right. Um, the environment is not being destroyed. All those kinds of nice things. Now, for $15 a pound, mm, it's got to be a once in a while treat. Can't be a regular thing. But so yeah, so I put the kettle on the stove to boil, and it boils. It starts to percolate, right? And as soon as it starts to boil, I turn it down. I turn the heat down, and I let it just perk for. I'm really into prime numbers, so I let my coffee perk for uh, for 17 minutes. 17 minutes. Hey there, Tom. Nice to see you in the chat. Yeah, I try to tweet 1 or 2 hours before the live stream, and then I try to tweet again when I start. And whether that does any good or not, I don't know. I've got about 270 followers on Twitter, so the word is getting out. The word is getting out, and you know I'm here just uh, as I've explained, right? I mean, I lead a pretty simple life, pretty simple. That's intentional, right? I'm not running around all over the place. I'm not traveling all over the place. I am sitting here working. I'm a working scientist, right? I'm a working um, um, astrophysicist, and so I mean, to do the work that I want to do, I need to be here working, right? I can't be traveling, I can't be going to conferences, I can't be communicating, right? But uh, it comes the end of the day, right? For me, uh, I'm 7 hours behind UTC. So this live stream starts at 2 hours UTC. If you subtract from that, right, that translates to 7 p.m. So my time, my local time right now, it's 7:13 p.m. on the 23rd. When in UTC time, it's 2:13 a.m. in the morning, right? On the 24th. So, that's one of the things that once you decide to get into astronomy, that's one of the concepts that you really have to just wrap your head around. Um, uh, is this idea of measuring time? Um, you know, get a sense of that, and I sort of use that as a gateway, right? If somebody, and that's why I never um, tell anybody when locally this live stream is on, because it's on at one time. There's only one time that this live stream is ever on, and that's on at 2 hours UTC. There's only one time. That's it. And it's right now. That's all there is. So, but, because we live on a sphere, at least theoretically, um, probably, uh, we have developed this idea of time zones, because sometimes the sun is over here, sometimes it's over there, sometimes it's behind us, right, and we can't even see it. So we have to develop these methods of measuring time. Now that's not defining time, that's just measuring time, and there's a big difference between that. If you want to try to get into defining what time is, bye bye. I will sit out of that conversation because it's going nowhere. Cheers. Hey there, Bobby. Nice to see you in the chat. Hope everything's going well. And yeah, I've definitely got the nerd love for sure, for sure. So yeah, hope everybody's doing well. Watched Fraser Kane with Isaac Arthur um, a while ago, and I um, I first heard Isaac Arthur pretty recently ago, within the past few months or so. I didn't realize how popular he was until I started listening to him and sort of you know listening around and doing a little bit of research. And then I started watching his shows and his productions, and they are awesome. They are awesome, and I'm wondering, really, I'm wondering. It's like Isaac, Isaac Arthur, what are you worrying about? Your speech impediment? Come on, dude. What? Who cares? Who cares? I've got a speech impediment too, and it's like okay, but yeah. So um, you know, Isaac Arthur, do what you're going to do for sure. Do whatever you want. But if you're talking about changing yourself in order to sort of meet our needs, don't do that on my behalf. Don't do that on my behalf. I think firmly stand on the side of be who you are. Don't change for me or anyone else at all. Now, if you feel the need to have to, fix some kind of, perceived problem, then okay, cool. That's fine. But I mean, I those kinds of things, I don't know. I mean, I'm not blind, right? And I'm not deaf, right? So I can see that there are differences. I can hear differences, of course. But so what? So what? Um, are you able to do what you want to do? um, People with disabilities of all kinds do lots of things that they want to do. Now, some things they just cannot do, right? Uh, Whatever kind of deficiency they have, sometimes it is an actual physical like impediment that just stops you. And it's like, okay, don't do that, right? But Isaac Arthur, dude, you're awesome. You're absolutely fantastic. Just how you are, just how you are. Your productions are absolutely fantastic. Your last one, which I'm not remembering what it's about now. Let me see if I can find it. Let me see if I can find it here really quick. Uh, Isaac Isaac Arthur. Got doggies barking on here for some reason. Probably another car drove by. Woo! That's the most exciting thing that happens here. Yeah, O'Neill cylinders. He talked about O'Neill cylinders, and I mean, Isaac Arthur really does a deep dive, right? A deep dive. I'm about to go yell at a couple doggies. All right, I'll be right back. Hold on one sec. those of you who have dogs completely understand this idea of, sometimes once they get started, they can't stop. They sort of need a jolt, and so yeah, that's all. He was just, I think a car went by outside, and sometimes, these doggies just cannot stop. Anyway, so Isaac Arthur spent 34 minutes and 52 seconds talking about O'Neill cylinders, and he just went on deeper and deeper and deeper and deeper. It was awesome. It was awesome, and um, you know, I guess I'm more about I'm much more into the content than into the delivery, right? I don't. I'm one of those that, you know, if I want to see a movie, I don't have to go to a theater, right? I'll just watch it on my, small screen, because I'm interested in the content, not necessarily, the oohs and ahs and, the delivery and all of that. And but even Isaac Arthur's delivery is awesome. It's absolutely awesome. So yeah, I only caught the last half hour of the interview with Fraser Kane. Um, it's really interesting, though. It's really interesting, and I have to say, okay, I have to say that it's got to just be a coincidence. Okay, it's got to be just a coincidence. But these astronomy types are they're they're all starting to sort of ramp up a little bit. Fraser Kane has now started a weekly Q&A thing. Right at the end of the interview with Isaac Arthur, it sounds like Isaac Arthur is going to be doing a live stream. So it's a little, you know, it's interestingly coincidental that I started a live stream a couple of months ago, doing astronomy, and it's sort of, maybe it's just my perception. It's entirely possible, right? Incredibly biased, um, but it seems like a lot of the astronomy um, type of podcasts and all that are sort of, turning it up a little bit, and I think it's cool. I think it's very, very cool. I think it's a wave. I definitely think it. You know, I my ego, right, wants to say, "Oh, it's me," right? But now I know better than that. I know better than that. I think it's a wave. I think this idea of this live streaming, and this concept that I just uh, learned what this meant. It's a IRL, IRL, which sounds like highly technical, IRL, and it just for those of you who don't know, that means in real life, in real life. So it's sort of a real life type of a thing. Miss Lady Catherine 313 is also in the chat. Hey, hey, hey. Um, Bobby and um, Miss Lady are over from Gilles' live stream. I think, Bobby, you're, well. I guess you. Um, I've seen both of you on almost all of Gilles' uh, stuff, right? You don't necessarily sit in one or the other. Is that true? So yeah, and Uncle Bill, this isn't exactly my real life, because I certainly do not talk out loud this much. Um, this is the most talking. I mean, these are the most words that I will say out loud um, by at least an order of magnitude all the rest of the day. These are just, I'm just voicing thoughts. The only real life thing here really is that, um, as I said, um, one of my motivations for starting this live stream was that I was sitting here anyway. Like I was saying before, I've got a simple life. And so I'm here, right? I'm here every single evening, right? And what am I doing? I'm thinking about astronomy, right? I'm going through papers. I am learning things. I'm doing my work as well. Uh, as a professional scientist, I'm doing my work as well. So my thought was, it's like, well, why not share that around a little bit, and you know, see if I can find a core group, um, group of people who want to get together and chit chat about all things astronomy. So here it is. Here it is. And so that's why for me it's absolutely no effort at all, right? I've got I've, I've got the smartphone here set to 6:45 local time. So that alarm goes off, and um, set the machine up, set the camera up, uh, start up the stream, and go, and that's it. Now, Uncle Bill just listed a uh, a list of in real life educational streamers on Twitch. I would love to be on Twitch, and but I'm going to have to wait until I can improve my technology and my bandwidth a little bit in order to do that. So for now, you're going to have to put up with this. I definitely, I mean, what is it called? Um, OBS. Okay, I I installed OBS on this machine here. This is a laptop, and um, after 10 minutes of playing around with it, it's like, wow, this is really awesome. You can set up anything, right? It's really, really, really awesome. But it brings this poor laptop to its knees. So it's just not going to happen until I can get a little bit uh, um, better machine and increase my bandwidth. My bandwidth here is extremely rural, as is my location. Cheers. Yeah, but I love OBS. I love OBS. It is, oh man, it's awesome. It's awesome. Um, anyway, so I think enough about that. I think the only other thing that I wanted to point out is that I am not, at least I'm not trying to portray myself as a science communicator. Um, that's something else. That's something else. I personally don't think that science is for everyone. I don't think that everyone needs to be turned on to science. I think there are people who will be turned on to science, and um, uh, you know, uh, my task is to find those and sort of bring them in, instead of trying to get everybody excited about scientific things. Not everybody's going to be excited about scientific things, just like me. right? I'm not excited about all kinds of other things. You know, I have a passing um, um, interest in most other things, but but you know, I mean, uh, yeah, I just think, at least for me, that is the wrong approach. I want to find my people, and you know, let the others go because it's just not their thing. There's nothing wrong with that. There's nothing wrong with that at all. Not everybody has to be, you know, on sort of the science bandwagon. Not everybody has to care. Not, no, not at all. Not at all. But I know that some of you do, and there you are. So that's cool. That's cool. And we're here, sitting here talking about at least one of the things, um, uh, um, um, which is astronomy. So IR hell, IR hell. Yeah. So yeah, this isn't really IRL. It sort of is, but as I said, I'm doing at least an order of magnitude more talking out loud in this hour or so than I do all day long. Right? I mean, I'm sitting here in my head. All right, let's talk astronomy for a while. Gee whiz. Get off your soapbox there, Cosmic. Jeez. So I pulled this up the other day from Stellarium. It's just well, as of yesterday, this is just the position of the planets as as they as they pretty much are now, right? So here's the sun. Let's see, how big does that get? Okay, let's just do that. So here's the sun, here's Earth, right? So here we are. So if we're standing on the Earth, we're looking, um, this perspective it is looking down on the solar system. So with that perspective, all the planets are going around counterclockwise, right? They're going around this way, right? And well, most of the planets are also rotating counterclockwise. Now, Venus is rotating clockwise, and Uranus is sort of rolling along its orbit. But everybody else is doing, you know, the counterclockwise thing. Yeah. I think Uncle Bill. Yeah, I mean, once I'm sort of I'm definitely wanting to move in that direction because I think, hey, there's Gilles. Nice to see you in the chat, Gilles. Uh, cool. Yeah, look, Gilles, this is a daily live stream. So you come in anytime you want. If you want to come in every day, every other day, every week, every month, every year, you are welcome. Welcome. Come on in. We'll talk astronomy and just have a good old time. Right? It's very casual, fun, but you know we're talking science here too. So you know it's not just a lot of fluff. It's you know some serious stuff. So here we are, sitting on the Earth, and if we look at the sun, right, we'll see that to the right of the sun is Mercury, right, and it's going around this way. So at the moment, Mercury looks like it's sort of moving away from us, right, because the um, the closer the planet is to the sun, the faster it moves around. Basically, because right, it needs to cover less um, distance, right? There's lots of other reasons too, but so Mercury at this point is going to be to the right of the sun, which means that it's up in the morning, right? It'll be west of the sun. That might be an easier way to put it, to the west of the sun, which means it is currently a morning object. And as you can see, if the Earth was not moving and we sort of move Mercury, I don't know, maybe to about here or so. So maybe this formed about a 90-degree angle here. That that would be about as far as Mercury would appear um, from the sun. That's called maximum elongation. And that's going to happen, I don't know, in a few more weeks or so. Of course, the Earth would have moved a little bit too. So yeah, yeah. Um, to the east of the sun, we will see Venus. And of course, if you look out, well, at least where I am, local time here is 7:36 p.m. Uh, if I look out to my west right now, I'm looking out my window here, I can see Venus, right? It's to the east of the sun, left of the sun, right? The cool thing is, see the geometry here? It's on the other side of the sun. It is way over there. It's way over there, but it's going to catch up, right? It's going to catch up, and it's going to reach its maximum um, elongation here in, I don't know, a couple more months as well, and then it's going to appear to get closer to the sun as well. So then we can look out to Mars. So of course Mars is beyond the Earth, so we can actually see Mars on our night side. You can sort of see this circle here. This is sort of an exaggerated uh, Earth, right? And this half, where my cursor is, kind of hard to see, I guess. Where my cursor is, that would be the lit side. That would be the day side, and this other half would be the night side, right, on the other side of the sun. And so this whole other side of the Earth can look out and see Mars, right? Of course, the people over here, right, can't see Mars because the Earth is in the way. But as it spins around on its axis, Mars is going to appear to rise and get higher and higher in the sky. And as you can see, Earth is going to catch up to Mars here pretty soon, next couple of months, I think. And Mars will be said to be at opposition, which just means it's on the opposite side of the sun. So the sun and the Earth and Mars are sort of all going to line up here, right? So these are just the positions of the planets as of yesterday, as of 2 hours UTC yesterday. I didn't update this for today because I was going to talk about it yesterday and never got around to it. Cheers. All right. Well, I also did the same kind of plot for the outer planets as well. So let's take a look at them. Dun, 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 dun. I like to have perspectives on things, different perspectives, and to have an idea of sort of where we are in relation to the sun and the other planets. I just sort of um, um, I don't puts me in a place that makes me appreciate all of this enormously. Now, this little green circle here is the orbit of Mars, right? So Earth, I think, is this yellow one here, right? That we really can't even see the Earth anymore. But all the other planets being outside of the orbit of the Earth means that we can see them uh, uh, at night, through the evenings or through the night. Uh, so Jupiter is coming up to opposition here pretty soon. Saturn, I think in the next couple of months. Um, and look, they're on the same side of the Earth or um, of the Sun as we are. Um, let's see. The stream is out of this world. Yeah, we think that we want to go out into deep space. People, we are in deep space. We are as far out as possible. So this idea of going to the far reaches of the universe, we are already way out there. We are way out. In fact, we are so far out, we have no idea where we even are. Okay. Um, the only thing that we can do is show our position relative to something else, right? So in this case, Hip, um, uh, this is the position of the Earth relative to the Sun and the other planets. So yeah, Jupiter and Saturn are on sort of our side of the Sun. Uranus and Neptune are on the other side of the Sun. So very, very cool. Uranus, you can barely see with the naked eye. I think it's like magnitude 5.8, something like that. Yeah, Neptune, I think is I want to say like ninth magnitude. I don't remember. I don't remember. Um, uh, but yeah, yeah. All right, so there we are. That's sort of the situation that we're in. The really cool thing, and I've only seen it shown this way a couple of times, is that the sun is also moving, right? It's going around the center of the galaxy. At least uh, that's what the observations say, and that's what the theories say. And so as these planets go around the sun, well, the sun is moving. So our actual path through galactic space is like this really amazing spiral pattern. It's like a multiple helix type of a thing. It's absolutely spectacular. So anyway, there we are. That's what's happening. That's sort of our positional situation as of yesterday, at least. So look, we've got some new messages over on the Discord. I'll bet you it's Uncle Bill. Yeah, yeah. Thanks, Uncle Bill. You're awesome. I'm just gonna take a look and see what else he posted here. I can't help it. All right. The other thing that I wanted to point out last night that I didn't get to was that I posted a link to where's that? Where did I never remember where I post things on this on my Discord server. Uh, here it is. Yeah, the International Meteor Organization. So this is just the the current meteor showers that are going on, and meteor showers are pretty basic, right? The the basic idea is, at least the theory goes, is that you have these objects like comets, right? That are, hurtling through, um, sort of the inner solar system, and they are leaving a trail. They're leaving a trail of dust and, you know chunks of things, um, mainly just dust, right? Dust is flaking off of the nucleus of the comet in some way. There are lots of ways, to lose material, and just leaving this trail. And this trail just so happens to pass through the orbit of the Earth around the sun. And so every year, right, because the Earth is going around the sun, every every year the Earth sort of intersects this path of debris, and we get what's called a meteor shower, right? And there's quite a few of them, and this organization, the International Meteor Organization, sort of keeps tabs on what meteor showers are happening, and how frequent are we seeing um, meteors in dark skies. And so this is very, very cool. And we can just choose whatever meteor shower we want. We just went through the Lyrids. So let's look at the Lyrids for 2018. Dun, 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 dun. So the Lyrids 2018 campaign. The graph below shows the zenithal hourly rate, which is the number of meteors that an observer would see under very dark sky, um, with the radiant of the shower at the zenith. Um, so the radiant is just that point in space where it sort of appears, where all these meteors are coming from. Now, if any of you have driven through a snowstorm, you will know exactly what a radiant is, because that is exactly what you see. Now, don't do this, at least not very much. But the next time that you're driving in a snowstorm, now be really careful, right? Because you're going to have to sort of change your attention, just a little bit, or just be a passenger, right? That's a better idea. Get yourself somebody to drive you around in a snowstorm, right? And especially at night, it's best at night, right? When it's nice and dark, you got the headlights on, right? And you're driving around. Now, you can do all kinds of experiments too. Just be careful. It is snow, it's slippery, but uh, you know, so at night in a snowstorm, doesn't have to be heavy, right? It can be any old snowstorm. It doesn't have to be heavy or light or anything else. But as you look forward, what you'll see is that all the snowflakes appear to come from a single point. Um, Now, because of several factors, that point will appear to move as well, and that's because of the wind. It's because of the speed of the car, um, the density of the snowflakes, all that kind of stuff. But it's very, very cool to actually realize what you're seeing, and it is the identical same thing, just that instead of being here on Earth, driving in a car in a snowstorm, we're standing on the surface of the Earth, hurtling through this cloud of dust. Um, and once in a while, a particle will interact um, with the Earth, and we'll have a meteor event. And so these folks count those events and report them. And as you can see, as of the 23rd of April, right at 21:42 UTC, so that's just a couple of days ago, the zenithal hourly rate was at 19 plus or minus 2. So somewhere between 17 and 21 meteors per hour. Um, so yeah, that's a pretty low number. That's a pretty low number. Um, um, yeah, 21 an hour. What is that? Well, let's pull out the calculator. This is an actual this is an actual physical calculator that, at least in my humble opinion, okay, every good scientist needs to have a hand calculator within arm's reach at all times, because then you can do these calculations like this and do 21 per hour, which is once every 2.857 minutes. Let's see, that's I can convert that. 2 minutes and 51 seconds, right? So every 2 minutes and 51 seconds on average, we are seeing a meteor from the Lyrids, and it's called the Lyrids because the radiant uh, is in the constellation of Lyra. And interestingly enough, the constellation of Lyra um, is is rising around midnight, and that's when all these things become easily visible. Right? You can see Lyrids on this side of midnight, but they're a little bit more rare. Once you get past midnight and start actually spinning into the shower, then you'll see a lot more. And it looks like, at least from this graph, right, the Lyrids aren't done yet. They look like that's quite an increase. So yeah, we'll have to pay attention a little bit and see what goes on. Now, let's look at one that has a different hourly rate, and you've probably heard of it. It's called the Perseids, the Perseid meteor shower. It happens in August, like mid August. So of course it hasn't happened in 2018 yet. So let's look at 2017, and we'll pull up the same graph and just see what that shows. The cool thing about this, right, is that this is actual data. This is not some guess as to, well, it might be this and it might be that. This is this is the actual data, right? So I think that that's very, very cool, because with this kind of data, you can get an idea of, like, the density of this cloud that the Earth is moving through, and not only density but shape, right? And that's very, very cool. So as you can see, the peak here looks like, yeah, it's a pretty sharp peak, right? I mean, it went from 42 per hour up to, what is that? 86 an hour. So it doubled um, in a day, right? And it looks like the peak here was at like 2039 UTC on Saturday, August 12th. So for me, I've got to subtract 7 from that. So that peaked for me midday. So I would have never seen that at all, right? So I'm going to see I'm going to see this stuff over here, and I'm going to see this stuff over here. But what is that, 86 an hour? Maybe 90 an hour if we take into account the error bars. So that's one every, whoop, I'm doing it the wrong way. 60 divided by 90. So that's one every 40 seconds or so. So that's not bad, right? That's not bad at all. I remember, I think it was 2000. I think it was 2000. Um, um, the Leonid meteor shower. Now, as I was just saying, these clouds of debris have shapes and densities to them, and it turns out that the um, the cloud of dust that causes the Leonid shower, we we move through a very, very dense portion of that cloud like every 33 years, right? So there was one in 1933, there was one in 1966, and there was supposed to be one in 1999 or 2000 or so. And the 99 one, I don't remember, so it mustn't have been all that exciting. But the one in 2000 was absolutely astonishing. Absolutely astonishing. Um, in fact, let's pull that one up. We can do that. We have the technology. So let's look at the Leonids for 2000. Dun, 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 dun. Let's see. Come on, where are you? Trying. Processing request. It's a lot of data. Here we go. All right, so check this out. Check that out. What is that? Come on. It's still trying to load here. Here we go. 364 per hour, right? 364 per hour, maybe up to 375 per hour, right? 375. That's 6 every minute. So once every 10 seconds or so, and that is about right. And the interesting thing, note what time it is here. 6:51 UTC. Okay. Now I'm 7 hours behind that. So that was at 11:51 or 23:51 UTC on November 17th, right? And I can tell you that was mind blowing. I've never ever seen anything like that before. It was almost scary, right? Almost scary to see that peak. And look how rapidly it rose. Look at this. This was 261 per hour at 5:42, and then about an hour later, it went from 261 to 364. So yeah, I remember that well. I mean, it was a great night, right? I mean, they were popping off really, really fast, and then all of a sudden, it just peaked, right? And that peak. So I saw that, and I will always remember that. Uh, I, the Leonids, as I recall, are moving pretty slow as well. Yeah, that's something that uh, yeah, we can look into that at some point. Because you know, you know, with observing meteors, one of the cool things about doing meteor observations is that having a telescope or binoculars is actually not a good idea, right? You want you want a lawn chair. That's what you want. Um, Something to sort of lay back and just look, or even better, get yourself an all sky camera and record the entire evening, and watch them later. Sort of meteor shower on demand. Yeah. Um, yeah, all sky cameras. Kip, you have to keep coming back here because I talk about all sky cameras quite a bit. I'm not going to talk about them tonight, though. But yeah. You know, do a Google search for all sky cameras, and you'll probably find a bunch of things there too. Um, anyway, this I think is a really cool resource, really nice. Not only for sort of the casual, the amateur, who just sort of wants to, you know, watch and enjoy these showers, but also for the scientist who wants data, right? So let's see what the Leonids did last year. Well, let's see what the Leonids did last year. Sort of a comparison, right? Let's do a comparison, and then I'm noticing that it's the top of the hour, so I definitely respect your guys' time. Don't want to take up too much, but I hope this is fun. I always have a fun time. So yeah, wow, look at that. So look at the difference here, right? 21 was the peak. 21 an hour. Uh, in in 2000, what was it, like 360 an hour? So an order of magnitude more than an order of magnitude less. So yeah, just absolutely amazing how dynamic and how complicated all these things are. And for me, that just makes me appreciate this and respect all of this so much more. It's awesome, awesome. Um, let's see. All right. I think, let's see, was there anything else that I posted? I just posted a paper that I saw on Archive about speckle interferometry. And maybe tomorrow night I will talk about that because I was and hope to be again involved in um, speckle interferometry. I got into speckle interferometry sort of in its mm, uh, early adulthood, when it was still sort of um, not well understood by the astronomical community. It used up a lot of computer time. At at that time, we just had a mainframe, so our data reductions would just suck up everybody else's um, computer time. Slow the mainframe down, so nobody else could really do their work. So we would run our stuff at night and all of that, and I think the entire place was so thrilled when we finally got our own machine. It was um, um, a Sun workstation, I think a Sun 110, if I remember right. Um, and um, uh, uh, we could do a lot of processing on that. But yeah, maybe tomorrow night I'll get into speckle interferometry because it is awesome. It really only has one sort of downside, and I'll get into that. But it is very, very cool. Should be taken advantage of a little bit more, I think, than what it is. But you know, it's complicated. So yeah, and it does have a limitation that sort of, you know, makes it, mm, you can't really do uh, uh, well, I hate to say serious astronomy, but you you can't really do much with it. But yeah, we'll get into that. We'll get into that maybe tomorrow or the next day. I'm going to stop sharing my screen here, pop back to that ugly mug. And yeah, I think I'm going to get out of here for tonight. Glad you all could stop by. Now share this video around. If you know others who you know have this passion, um, as I said, you know, this isn't um, uh, uh, intended to be um, um, like an educational channel. Education is going to happen, but that's not why I'm doing this. I'm doing this because I'm sharing a passion, and uh, you know, if you learn things, I mean, I am definitely learning things for sure, and you probably are too, and that's very, very cool. But the intention here is just to gather a bunch of friends around and talk about a thing that we all like, and that's it, and that's all it is. We're definitely going to learn things though, and that ain't bad. That ain't bad at all. So all right, I'm going to get out of here. Yeah, yeah, the mothership is calling and my coffee is cold. Ah, bad news. Bad news. So yeah, I'm going to get out of here for now. As I said, share this video. If you're new here, make sure to subscribe. You can hit notifications, hit the thumbs up. I think that helps. Hit the thumbs down. I think that probably helps too. So whatever you want, make some comments if you want. I'm always happy to read those and respond. Um, and yeah, I think that's it for tonight. I hope everybody has a great evening, a great day, and yeah, as far as you know, so far in my limited amount of experience, tomorrow has come. So I think I will definitely see you all tomorrow, same time, same place. Dare to be nerdy. You know, it's the triumph of the nerds. We all run the show. We really, really do. All of us. All of us. Not just the nerds, all of us. We have enormous power. We have enormous power that, you know, we usually just give away. And I think that we should hold on to that a little bit more and use it, use it as opposed, you know, to giving it away to others. So yeah, let's do that. Now hold on to your hats because the Earth spins and we're moving at about 1,000 miles an hour or so right now. So it's, you know, it's hard to stay vertical when you're moving that fast, but somehow we do it. Hmm, don't understand that yet. Got to figure that out. Maybe it's just because we're used to it. I don't know. I don't know. All right. Peace, cheers, and I will see you on the spin tomorrow. A little less than 23 hours. Okay, bye.